everybody. Thank you so much. So today, my name is Moshe Zadka. My website is cobodism.com, where you can find every way of reaching out to me known to humankind. And today I'm going to talk to you about why you should back off and give up. I want to start with an acknowledgement of country. I live in Hayward in San Francisco Bay Area, which is the ancestral homeland of the Ohlone people. So we all want to build resilient systems, right? Things that don't fail. And I'm sure you've all heard, like what you should do to be resilient, right? Try again. If at first you don't succeed, never give up, never surrender, right? Like all good. But I'm gonna suggest that the secret is really to know when to quit. And so what is the problem? Right? Why am I trying to convince you to quit? So this is what you get. Kind of like if you naively write code, right? You write some middle layer in your microservice architecture. It needs another microservice. You call it the other microservice, occasionally flops. The network occasionally flops. Things time out. Stuff happens. So you start writing a retry loop like that, right? This is the most natural thing that a developer will do to get things to not fail. Well. So what happens when this happens at runtime? Well, the service behind that, the service that we're trying to call, might have a small outage, right? The problem with a small outage is that now everything a lot of requests, all the requests that have gone in the last few seconds, are going to are in a retry loop, and now as soon as it comes up. It gets all of them, right? It gets 5 or 10x the load that it expected. And when services get 5 or 10x the load that they expected, they crash. Now, what happens when it crashes? Everything goes into the retry loop, right? So that means when it finally recovers, it crashes again. So you've just turned a 5-second outage into a 5-hour outage. That's bad, right? We don't want to do that. So, and typically, it's even worse, right? Because, like I said, it's a typical microservice architecture. You probably have a few layers. So, and of course, at every layer, someone was exactly as smart as you, right? So they built kind of a retry loop, which means if the payment service is starting to fail 1 in 3, then the API gateway will start failing a bit more. And so the front end will start retrying the API gateway. And you've just turned what is 1 request into 9, and of course you're not getting 1 request, you're getting 100 requests, and now you're at 800 over the request you're planning to get, and since your service was never designed for that, right? And if your service is designed for 1,000, then it's probably not designed for 9,000 and so on. Once again, the whole thing will crash, and it will be sad, right? Basically, naive retry loops are a good way to turn a small outage into a big outage. Small outages happen all the time, right? The network hiccups, the some S3 bucket is getting slow for a bit. This is a really efficient way to magnify that storm into something that will take your service down for hours. So you've probably learned I should do backoff, right? So the most obvious way to do the backoff is exponential. And let me give you the theory, the intuition, why do we want to do the exponential? Imagine that we do an exponential with 2, it doesn't really matter, all of them are it has the same argument. Then the total time we'll wait will be proportional to the total outage time, right? If the outage was 5 seconds, and we're at a 2 exponential, we'll wait 8 seconds to 16 seconds, right? If the outage is 10 seconds, we'll end up waiting 16 seconds to 32 seconds, right? Which means that we wait efficiently by the outage, right? We're not causing more delays than we absolutely have to, except by a constant factor, but we're kind of not storming over the thing, and we're not doing a lot of retries, which means that we'll be more efficient, right? We're not throwing away our own CPU. So the wait is proportional to the outage time. We all know how an exponential looks like. You do 2 to the attempt time, and you do time sleep, right? So this is basically if that code that I showed you before had that time sleep, then at the very least like when the service comes up, things kind of like, not everything will attack it at once. But what ends up happening is that things are correlated, right? Which means that, like, sure, like, the exponential kind of like, doesn't track exactly, but it doesn't track not exactly either, right? Like, it tracks well enough to be correlated, which means, like, you might not be as efficiently bringing it down, but you're still gonna bring it down, right? Because at t for a second, right, when, like, everything wakes up, everything is gonna get hit again, then it's gonna go down, and now you've again turned your outage from like 5 seconds to 5 hours, and it's bad. Right, so this is how I like to do jitter. Some people like to do more aggressive jitters, like, they do like random uniform 0 to 1 or 0 to 2. I don't like that because, again, I like to keep it somewhat constrained, right? Like, like I do want to like have the outage proportional, right? Like, if it's if it's a big outage, I don't want anything to kind of like retry on a 1 second basis. You're gonna have like just a lot of like, unnecessary retries. This is kind of like smears it just enough. And again, it's kind of proportionally smearing, right? Those 10% are gonna be more meaningful the longer the outage is. So that ends up working pretty well, and this usually is a reason. In real life, you don't want like, just, as we all know, I'm sure from experience, exponentials go really fast, really high, right? Like, it doesn't take a long time to wait until the exponential is just ridiculous. You don't need anything that waits a day, right? Just like useless, right? So usually people will put max timeout. And I very intentionally like put it as constant and didn't tell you the number, because here are like 2 examples of numbers, right? They're almost numbers, right? Like, there's like 30 seconds and like 10 minutes, right? We convert it to like seconds, and we have like some max timeout. We could use every one of those, right? And if you think back, like, that's not a big decision, right? And big decisions like sometimes are decided by like a handful of neurons. At that layer, like quantum effects can actually appear, which means like, we are like already at kind of a point where in reliability, right? We kind of like split into multiple worlds, right? Where like, like someone makes a decision. So let's talk about the worlds. Let's imagine that we live in a world where like we're building a recipe recommendation site with an ML backend, right? Like very standard, right? Like, we kind of like, get all what we know about the user, like, the browser fingerprint and the time and like, whatever. And we put it in the ML backend. The ML backend like predicts which recipe the user is gonna like, and the users like it, right? And like in this hypothetical, we assume we have a good ML team, right? Like they do a good enough job that our site is getting popular. But that's great for us, of course. But they're not perfect. They're just a good ML team, not a perfect ML team, right? So they roll out a new model, as an ML team is wont to do. And as ML teams are want to do, they have an overfit. In this case, it's an overfit on time. Right? Why does it matter that it's an overfit on time? Because this is a ticking time bomb, right? Like, right now, we rolled out, like we finished the rollout, right? We finished the blue-green or whatever it is that we do to roll out. Everything is on it. But we have a ticking time bomb, right? Like, once it's 1 p.m. and the overfit on time happens, it triggers a latent bug in the ML library. So that means at 1 p.m., all our models are gonna crash. Not reliably, but let's say that it happens like, for 1 every 10 users. Well, like there's probably like more than 10 requests going to a given ML backend, which means that like at some point, like, it will crash. Then of course it will recover. And now we know what's gonna happen, right? Like, it goes into a retry loop. The retry loop goes into an exponential with jitter with the max back off. And as you remember, we live in 2 different worlds, right? One is the world with the 30 seconds, one is the world with the 10 minutes. So, of course, in both worlds, we roll out a fix, right? We want to fix it. And we do like the typical kind of rolling rollback, right? So like, we roll back like, the model kind of like, on one instance at a time until we reach everything. Of course, we don't want to like, do any storms. Bad. So let's think about how these 2 worlds will react. Right? In the world where the max backoff is 30 seconds, when we roll out, this node, the node that we just turned on, has stopped crashing, right? Now it has a good ML model. Of course, all the other nodes are like, kind of in a crash loop, so everything that's connected to them, like, doesn't work. So like, everything will eventually connect to us, which means now this one poor node has to sustain the entire website. And as we agreed, once you have to sustain like, more than what load you've handled, you usually get an outage. It doesn't matter if it's like literally failing or if it's just like, not serving or like, just very low latency. What happens is that this node, for all intents and purposes, is not functional anymore, right? So like everything goes back into the retry loop, which means, which means that when you bring up the next node, it doesn't have anything to kind of like, take over the load, which means it's gonna fall down. And so even after we have finished the rollout, we have theoretically a good ML model, right? Like everything should be working, but everything is in a crash loop because anything that wakes up and starts up gets all the overhead. It crashes or like, at least goes into an outage, and then the next thing goes up and like, it's not good, right? In the other world, as we talked about, it's 10 minutes, right? 10 minutes is often enough time for it to warm up. But even if it's not time enough for it to warm up, it's fast enough for a human SRE to do something about it, right? The human SRE can like start like, playing with parameters to make sure that like, in these 10 minutes, we actually manage to like, do a nice rollout. The only option that the SRE has in world one is taking the whole front end offline and putting it back. Now, assuming that we did like a good job on our recipe site, which means like, say we have a non-ML fallback, that's very big degradation, right? Like, we're almost at a place where like, no user noticed. Now we have to take the whole website down and bring it up. In this case, because we could like, play around with parameters, because we let things like warm up the cache, because we let things kind of like, get up, 10 minutes, and like, it kind of sounds funny, but like, you want to use human time, not computer time, right? Computer understands 100 milliseconds, 2 seconds. Humans can't do anything in 2 seconds, right? Like, by the time you finish the sentence, it's already 2 seconds later. Humans can do things in 10 minutes, and that's a really big thing. So you really want to have a max backoff that's human compatible. Now, of course, I described it so like you're going to write the code yourself. In real life, you're not going to write the code yourself, right? You're smart enough to not do that. There's a library called Tenacity. This is how you usually work with Tenacity. You do retry, you can do weight exponential. In real life, you should probably configure it for the jitter stuff. I guess I forgot to do that now. But it has all the things you need. You just decorate the function that calls stuff, and you don't have to worry about anything else. Often you could do it at a layer of like, like everything that you call an API, and you don't have to think about it anymore. So this is very useful, right? And this is a good retry loop. However, this all works really well when things kind of recover, right? But another thing you want to do is like also, as once like the whole service, not like on a node basis, is starting to go down, you want to start using it less, right? You want to start like, just using the fallback kind of preemptively to kind of let it sustain, right? So for that, there's like, you want to basically like, let it retreat. That avoids catastrophizing, right? That avoids, again, making a small problem a big problem, right? If you just start using it less, you start kind of like, not sending it traffic once you see that it's offline, right? So the difference between that and the retry happens on like a per request basis, right? So like every request, you start like, thinking like how much should I retry? But like if things are failing enough, you don't want to do the first try, right? The first try might be the thing that like, already breaks you, right? In a kind of complicated enough scenario, right? So you want to say, okay, if all the requests I'm sending to this service are like not useful, I'm just not going to I'm just going to stop, going to this service, right? I'm going to assume there's an outage. I'm going to let it recover. I'm going to let like the whatever SRE or auto healing mechanism, let it recover and then bring it back up. And that's called the circuit breaker. Now, circuit breaker is obviously a metaphor from electrical engineering applied to software engineering. The reason I'm saying that is because electrical engineers, no offense to anyone who kind of, was trained as an electrical engineer, objectively electrical engineers are weird. And specifically, they're weird because they think the opposite way, right? Like, if you deal with like, literal circuits, right? And like, switches and like, whatever it is that like, electrical engineers do, closed is the good one, right? Closed means that like, the current is running, right? Open is a bad one. Open is like, you can turn it off, right? So like, well, you might intuitively think that closed is when you don't send information, and open is when you do send information. That's the opposite. Closed is everything is going as appropriate. So I say that because like otherwise it will be hard to understand the state diagram of circuit breaker, which starts out closed, right? Like, hopefully, most of the time, your stuff is not failing. Right? If your stuff is failing most of the time, maybe like that's what you should fix first before figuring out how to retry. So most of the time you're in a closed state. Most of the time you're just sending stuff to the service. However, when you get enough failures, you activate open mode. Open, like I said, remember open is like turning off stuff. So you activate open mode, which means you stop using that service, at least from that instance. Sometimes you do it at the load balancer level, like all kinds of ways to do it. You move into open state. Open state means you're not sending it any traffic, right? You're doing whatever fallback you have. You're sending failures from the API layers, whatever it is that you would do if the service was actually out. Hopefully, you planned for every service to be out and for some sort of graceful degradation. Even if the graceful degradation is sorry, we can't help you right now, here's our support number, that's still a graceful degradation. But what's interesting is like if we keep it at open, then it doesn't send traffic to the service behind us, which means when it recovers, is like if you don't send traffic, you can't know it's recovered. So this is the half open state. The half open state is when you send like small amount, like let's say 1% of the traffic, right? So kind of you just randomize and you send 1%, right? If that 1% is starting to get more and more successful, you move back to closed, right? So like that circuit diagram, that state diagram always goes in like one way, closed to open to half open to closed and so on. So like that's a really good way to kind of like, remember that like, there's only one path. It's not really a complicated state machine. It's like a state machine where every state only can go to like, one state or like, stay the same. So very simple state machine. However, even really simple state machines, you're probably better off not implementing yourself, which is why you can use a library called PyBreaker. Again, you can just decorate stuff. You can say max fail and reset timeout, which configures like the parameters of the state machine, like how many failures before I move it to closed, how long before I kind of start moving it to half open, stuff like that, right? So that's PyBreaker, which means you can kind of use it in tandem with tenacity. Probably if you are, put the tenacity on top and the PyBreaker on the bottom so that you kind of break before you kind of start retrying. Otherwise, you'll break less often than you should because the retry will kind of pretend it's successful more than it should. So if you are using it, think carefully about like how Python decorators work and like kind of put the decorators in mindfully. So PyBreaker also supports load shedding with priority levels. So it can say like, okay, when it's like just starting to fail but not failing a lot, let these ones through and let otherwise through, and like you're deciding on priority levels, right? Like, maybe you have some sort of VIP customer flag, right? You probably want to serve your VIP customers, right? Maybe you have like two different flows, right? Like, maybe the ML recommendation is less important than the purchase one, so you want to use that, right? So like, there's all kinds of like, reasons to like, do priority levels, and that's like obviously like literally a business decision. You need to think about like, what is like the money value of like, each hit you get. And you can also, like I said, do a fallback. So instead of failing, right, it'll still do that, but it'll still give you something, but it will give you like an empty list. Again, with recommendations, really useful empty list, a useful fallback is an empty list. Then like, sure, like, the website looks a bit weird with like, the ML recommendations on the site being empty, but that's much better than like a complete failure. So it's kind of okay. So let's talk about how you can kind of put it all together, right? Like what is a typical configuration, right? So in your retry loop, you have a max delay, let's say 5 minutes. In your circuit your circuit breaker, you put a failure threshold of 5. So like, if something has failed for 5 times, probably there's like a problem. Recovery timeout 60 seconds, it's probably a useful kind of compromise. And you say, okay, I need most of my priority in reports, recommendation after that, and anything that's explicitly marked as non-critical, I'm going to assume that like, the person who marked it non-critical knew what it was doing, and I'm going to treat it as non-critical. So now, if you have that, and it activates, there's a failure, right? Like the fact that like you're recovering from the outage, or the fact that like you're avoiding catastrophizing is great, but you still need to fix the problem, right? You still need to like operate the outage. Now, because of that, you want to monitor everything. Luckily, all these things, like what to monitor, right? You monitor failure rates. Yeah? You monitor like how many retries you had, right? You monitor like total time. You monitor like what state your circuit breaker is. Like all these things are already kind of inherently good monitoring signals. If you just make sure that you send them to your monitoring framework, then you already have a lot of useful metrics, and you already have a lot of useful alerts, right? Because now you can decide, like, okay, if I get more than X things activating the circuit breaker, I should probably let someone know, right? So this is kind of inherently, and this is like, I guess, kind of to go back to like, a previous talk, right? This is part of the rigor here, right? Like, you want to make sure that like, you're prepared for what's going to happen. You know that like, you're tracking these things. You know that you're going to get an alert, so that when it happens, sure, you've given people the 10 minutes they need to kind of respond mindfully, but they need to respond mindfully, right? You need to have alerts, you need to have runbooks, you need to have like the whole rigmarole. What do I hope that you'll take away from here? There's only one correct solution for backoff, which is exponential backoff with jitter. The exponent matters a lot less than the exponential, than the idea of the exponential backoff with jitter. That's because pretty much every exponential goes to infinity super fast, so it kind of doesn't matter. Which means you can do a lot of things that doesn't look exponential but is exponential. Like one of my favorite things is the Fibonacci sequence. The Fibonacci sequence is exponential. Read like any common proof in a math paper. It's a very popular result. But at the low end, it's really, really good, right? Because the Fibonacci sequence starts 0, 1, 1, which means the first retry you do immediately, right? Like, if there's just a small problem, you do want to kind of like not have any, then you kind of like, have like 2 ones, right, for like, the minor problems, and then you really start to go into the exponential. So I kind of like the Fibonacci sequence, but that's really a personal preference. Max backoff, you don't want more than 10 minutes, because at that point, like, it's pretty useless. Nobody is waiting for something 10 minutes. You don't want less than 10 minutes, or like at least less than like, say, 5 minutes, because that's gonna kill your stuff anyway. And finally, you need to put like a breaker. You need to give up so that you don't overload your stuff, right? And that is like how you can make, and also make sure that like, in the situation where you're already constrained, where things are already close to failure, make sure to prioritize. So this is what I hope you take away from it. The real way to make sure that your system doesn't fail catastrophically is to make sure that you've planned for the small failures and avoid catastrophizing them. What all these things do is mitigate the inevitable failure. It means that like in a typical microservice architecture, we have one microservice that's like, for some reason, the latest rollout of that is like a not good rollout. You're not bringing the whole thing down in a way that like, you can barely recover without literally like, turning everything off and on again. So I mentioned 2 libraries, Tenacity and PyBreaker. This is how you pip install them. So like, useful to get like the actual name.